Hi, and welcome back. In this lesson, we will discuss several attributes of the pandas DataFrame object that you will frequently need while cleaning, pre-processing, or analyzing a dataset. Moreover, we will use the lending company data as our example object. Right, let's just start. We can refer to the index attribute to obtain an object containing our DataFrame's index elements. There are 1,043 elements, apparently, all integers running from 1 to 1,043. Please don't mistake this numbering for the default integer index, which in this case would have started from 0 and run until 1042. Moreover, this is a particular int64 index object. That's the object type automatically assigned to a numeric index of a data frame. It is indicated just before the opening parenthesis here, or as an output of the type function, executed in the next cell. Analogously, we can apply dot columns to obtain an object that contains all column names. This is very important information that you will often use when adjusting or reorganizing your columns. In addition, it's of the index type. And this makes sense when you think of it. Column names act exactly as an index when you are looking at the table horizontally, so to speak. In other words, they can also be used as a point of reference to a data value. Then, you might want to combine the outputs of the index and columns attribute in the same field. There's a separate attribute for that, and it's intuitively called axes. Okay, another very useful attribute of the pandas data frame is D types, meaning data types. It displays all column names on the left and their corresponding data types on the right. You will constantly need such information throughout the date cleaning and pre-processing stages of your analysis. The reason is that keeping track of data consistency is a main goal for a data analyst. So, obtaining information about the data types of each column in such a quick and efficient way is a great advantage. Next, we will focus on the comparison between the values attribute and the toNumPy method. Dot values will deliver a two-dimensional NumPy array representation of the values of the object. Thus, every row from lending company data will be stored in an array, and all those inner 1D arrays will be stored together in a 2D outer array. Similar to the case about series, pandas developers advise us to switch to the toNumPy method when we need to convert our data frame into a NumPy array. However, the technical reasons for this suggestion are beyond the scope of this lecture. It will suffice to know that dot values and toNumPy intend to solve certain compatibility issues in the long term. Nevertheless, you can see that the two techniques lead to identical outcome. This is further proven by the result of executing the type function. No matter which technique you will encounter in your work, it is important to remember that there is a solid relationship between the pandas data frame and the NumPy two-dimensional array. This connection can be exploited through a quick conversion of the object type from a data frame into an array. Great! The last attribute we want to explore in this lecture is shape. When you refer to it, you will obtain a tuple that will show you the dimensionality of the object and the number of elements there are in each dimension. For instance, for lending company data, we have 2 elements in the tuple, which means the given object is two-dimensional. And of course, lending company data is a data frame. Moreover, the shape tells us that there are 1,043 rows in our dataset, as well as 14 columns. Please note that the index column is not included in this representation. To check that, you can scroll up to verify that the columns attribute did not retrieve the lone ID column in its list. Then, you can use that same expression as an argument of the Python built-in len function, which results in 14. This is also exactly the output of the shape method. Nice! In this lecture, we grasped the most notable attributes you will need while working with data frames. In the next one, we will switch our focus to indexing elements from a data frame. See you there!